In this video, I'll be going through question 11 from the 2012 exam. In this question, we have to state the number of slack variables and the number of artificial variables for both the given problem and its corresponding dual. In order to answer this question, there's two things you need to know. One, when to introduce a slack variable. And two, when to introduce an artificial variable. The first one is easy. You introduce one slack variable for each constraint. For the second one, you have to look at the form of the constraints. You introduce one for each constraint of the following form. If you have a1 x1 plus ... plus an xn is greater than or equal to b, or a1 x1 plus ... plus an xn is less than or equal to minus b, where b is strictly greater than 0. So now we can use the information given to us in the question to write down the answer straight away for the primal problem. In part A, we have two constraints, and so we have two slack variables. Both of the constraints are of the form something less than or equal to a negative number, and so we're going to introduce two artificial variables as well. We'll save the dual problem for later and move on to the primal problem for part B. We have two constraints, so again, two slack variables. The first constraint is of the form something greater than or equal to a positive number, but the second constraint is not, so we're only introducing one artificial variable. And for part C, we've got four constraints, so four slack variables. And only one of the constraints is of the form that introduces an artificial variable, namely the third one here. So we get one artificial variable. The next thing to understand is how many constraints there are and what they look like when we transform the primal problem into the dual problem. The number of constraints is easy. The number of constraints is equal to the number of decision variables in the primal problem. So we can write this down straight away. So now for the dual problem, we can write down the number of slack variables. For part A, we have x1, x2, and x3. So we've got three slack variables in the dual problem. For part B, we have x1 through to x4. So we've got four constraints in the dual problem, and hence four slack variables. Finally, for part C, we have x1 and x2. So we're going to introduce two slack variables in the dual problem. To count the number of artificial variables, we don't actually have to know the constraint in full. When we convert the primal problem into the dual problem, we get constraints of this form. Something greater than or equal to something else. It doesn't matter what appears on the left-hand side. All we're interested in is what appears here. And what appears on this side are the coefficients of the objective function. It's important to remember to consider the problem as a maximised problem before we convert it into the dual problem. So, to count the number of artificial variables, we'll count the number of positive coefficients in the objective function. Part A is already of the form of a maximised problem. So we count the positive coefficients. We have positive 2, positive 4, and negative 7. So we've got two positive coefficients, and we'll introduce two artificial variables to the dual problem. Part B is also a maximised problem. We've got negative, negative, positive, negative. So we've got one positive coefficient, and so we'll introduce one artificial variable in the dual problem. Finally, for part C, note carefully that it's a minimised problem. So to really be sure that you're writing down the right thing, write down the corresponding maximised form. Which is here minus z equals minus 7x1 plus 13x2. So we've got one positive coefficient, and thus we're going to introduce one artificial variable into our dual problem. And now we've finished the question.